All right, now previous class we stopped at principle of work and energy. So basically what does this principle of work and energy is say that the change of work done, right, or the work done equal to the change of kinetic energy, right? Half mv square is kinetic energy, right? So you take the energy after minus energy before. Okay, so this equation we name it as principle of work and energy, right? You can write in this way: sum of u sub 1 to 2 equal to T2 minus T1. So this is a form. Okay. Then, if in the exam, for your info final exam, there is one question confirmed come up from chapter 3. So if this question, if the question asks you to solve using principle of work and energy, this equation is expected in your answer sheet. Yeah. So you just rearrange the principle of work and energy equation. U sub 1 to 2 equal to T2 minus T1. You either write this one or you can write this one. Same. So a more complete equation is this one because with the sum of energy. Right, this one without sum. Okay, so more complete equation for principle of work and energy. If right, this is what we prefer to see compared to this one because this is more complete. This one with the sum of kinetic energy at point 1 plus the work done from point 1 to point 2 equal the kinetic energy at point number 2. Okay, so this is what we expect in your answer sheet in coming final exam. And we have went through example 2 before we stop for last lecture. Today we look at one more example. Okay, today we look at one example. As can also refer to the same question in your tutorial handouts, right? So we have a crane that moving an object with a cable wire over here. So as you can see, this cable wire made of a triangular shape, right? Two cable wire at the both end, and there's object, and then there's a cable connecting to the crane here. So for a short time period of time, the crane lift 2.5 megagram. Okay, this is not kilogram. This is 2.5 megagram. So you need to change the unit of mass into kilogram. Again, when in the calculation for this engineering dynamics, you need to use unit SI. So what is the unit SI for mass? It is kilogram. It's not megagram. So you will see something like this in your test 2 or in your final exam. Okay, so if you see this one in a test or final exam, if you're not sure, you can ask, right? You can ask during the test to confirm what you see, right? Right. So this is megagram. Beam, meaning this beam here is having a weight, having a mass of 2.5 megagram. So you need to change this one to kilogram. With the force given by one equation, so this force is changing with a quadratic equation. F equal to 28 plus 3x squared kilo Newton. Again, here come with kilo Newton. So in your calculation, the unit SI for force is Newton. It's Newton. So here come with kilo. So be careful in your answer. We have kilo, we have mega here. Determine the speed of the beam when it has raised 3 meter, meaning here raised 3 meter. also how much time it takes to attain this height starting from the rest. Meaning you are moving this beam from rest, moving from 0 to y positive, mean this one move up with 3 meter. You have the displacement s, or you have the position s, 3 meter. You have the force, you have the mass. Okay, so this kind of question, you know that you need to use equation of principle of energy and work. Because why? The question gives you speed, asks you to find speed. You have the force, you have the distance. All right. Because again, recall what is the principle of energy or work. Kinetic energy 1 plus the work done from point 1 to point 2 equal to kinetic energy at point number 2. So you're dealing with kinetic energy, m half mv squared. Here you have the velocity, right? So you have the velocity. So it tell you it start from 0. Then it also asks you to find the speed. So the equation half mv squared you need to find. Plus the work done. Again, recall what is work. Work only concerned of 2 things only, which is force and displacement. So when the force go parallel of same direction with the displacement, then the work is done. Okay, positive work. When both move in the same direction, you have a positive work or plus u, right? Positive u. What happens if the work is perpendicular, right? Perpendicular 90 degree to the displacement, you get 0 work because you have the cos theta. Cos 90, 0. And the work go behind of the displacement direction, you get negative work, right? You get negative work. So this concept you have to be clear when you try to solve chapter 3 question. Yeah. First, what is work? How work generated? So you concern of force and displacement. Here, you have force. You have the displacement of 3 meter. So basically, by using the principle of work and energy equation, you manage to solve what is asked by the question. Yeah. So first, you draw the free body diagram. This statement already seen this statement in the beginning of this chapter. So principle of work and energy, we deal with force, velocity, and displacement, like what I explained just now. So we have our force here. We have a force F equal to 28 plus 3s squared kilo Newton. Here is kilo. So if you miss out the kilo, the rest of the answer will be wrong already. So at S equals 0, meaning at the beginning or initial, what is the force acting on the beam? So S equal to 0, you substitute 0 here, you get force equal to 28 kilo Newton. Reading, before start, the cable was pulled at 28 kilonewton. Then check your W, right? W you know equal to mg. So again, mg, m here is in kilogram plus the gravity, yeah? Kilogram plus the gravity acceleration, m as minus 2 or meter over second square. So we get 2.5 10 power 3 in kilonewton, in kilogram. The question asks you in mega, given you in megagram, you need to change 2.5 megagram into 2.5 kilogram. You know mega is 10 power 6. You change 10 power 6 into 10 power 3 in kilogram unit times 9.81 Newton. Any questions so far for converting the kilogram into megagram into kilogram? Good, eh? Steven, are you okay?
Yes, sir.
All right. So you get the W, weight equal to 24.525 kilo Newton. Okay. The first force when it's before start, your force is 28 kilonewton. So your weight acting on the body itself from the center of gravity, you get 24 something kilonewton. So you have two force here. Okay. Now, what is the purpose with checking the force and the weight at the initial point? If the force before it start is more than the weight, if the force of pulling is more than the weight pulling down, what will happen to the beam? Okay, try to imagine. It's a logic, physical, engineering question or physics question. You have the beam before start 28 kilonewton pull up, weight pull down 24. There's an excess of forces, imbalance of forces acting on the body. What happened to the body? Nageshwaran, are you there?
Yes, sir.
What happened to the beam if your force
It
pulling up is
will,
more than W?
it will move upwards.
It will move upward, yeah? It will move towards the positive or excess forces direction. All right, positive here. Okay, so this is analysis that you need to done before you solve the rest of the question by using principle of work and energy. Yeah? So you have to know where is the direction is either going up or going down. Yeah. Okay. Next, you draw the free body diagram. So by looking at the picture and also the statement above, are you able to draw a free body diagram? All right. So this module, most of the time, I can say 80% of the question, you need to draw free body diagram. Okay. So what is the main body that you need to draw here, focus on, is the beam. So you draw a beam with a cable, right? You draw a beam with a cable. The force, although there are two cable here, right? So there's a force pulling up. We already find what is the force when it start just now. Force equation, force equal to 28 plus 3x squared kilonewton, right? So this one will change with the displacement. And then there's a weight pulling down, W. Okay. So you know that displacement is going up, right? You know that when you pull out, displacement move up. This one, displacement pull up. So displacement move up, force move up. You generate positive work. Okay. Force move up, displacement move up. You get positive work. W, displacement go up, force go down, you get negative work. This is just a remark there. Of course, in exam, you don't need to write this one. This is just for your revision notes. You apply the principle of work of energy, write the general equation in this module. When you try to solve a question, general equation will give you some point there. Okay, minimum 1 mark, maximum it can go up to 2 marks to 3 marks just to write the general equation. Okay, so this is the principle of work and energy. For example, the question asks you to solve using principle of work and energy. What do? You write in your answer, principle of work and energy, you write this equation, you score 1 to 3 marks in that range. Okay, so all the kinetic energy at point 1 equal to the work done in the system from point 1 to point 2 equal to all the kinetic energy at point number 2. Okay, then expand this equation. T, kinetic energy, equal to half mv square at point 1. So you just label v sub 1, same as point number 2, half mv square, but sub 2 because it's point number 2. What is the work done? Here you have two forces there. You need to be careful. Huh? This is the careless mistakes done by student. So how do you know that you are writing the correct answer? For work, you need to consider all the forces inside the free body diagram. Again, this is a very direct question. What happens if the object slanted at a certain angle? This is a very strict question. Very straightforward question. What happened? I re-engineer the question. I flip or I rotate the beam to 30 degrees. Meaning I add a statement. During the lifting, there is an imbalance of force happen, and I tilt the object here. Right? So you need to be careful on that. Yeah. And also, yeah. So the main point for calculating the work here, you need to consider all the forces inside the diagram. So as long as inside the diagram you have forces, you need to consider if that force, individual force, have a displacement or not. Usually have lah. Usually have. Okay. So the first one is force. Force equal to force times displacement. You get work done by the force. However, why we integrate? Because your force is in the equation. Right? Your force is in the equation. So this is just a example. So every time you see equation in the question, expect integration in your working. Yeah. It can be force. Sometimes it can be the weight of that object. Right? The weight of that object. For example, I'm lifting a water tank. However, there's a leaking. There's a leaking of water in the water tank. So W, or mass of the water tank, is given by one equation. So you will have integration in the calculation. Yeah. So something like that. Right. So for this example, your work have two force involved. Force going up and gravity going down. Right. Your weight. So the force positive, integration of force ds, yw negative because it's going down and the displacement direction is going up. That's why you get negative ws. Any question for this equation? Any question?
No, sir.
No.
Yeah. All right. The rest substitution. Let me ask question. Yeah. Okay. Sivendra, are you there?
Yes, sir.
What is the velocity v1? What is
Should be
v1?
0, sir.
Correct.
Starting from here, so it should be 0.
Yeah. So correct. So v2, we need to find. The question asks us to find v2. F we have. W we have. Displacement we have. So basically there's only one unknown there, right? So Again, here involves some integration skill here. All right, so just now, our friend already helped us to solve the first equation here. Right, you start from rest. You start from rest, so V1, 0. So basically this one equals 0. So in your workout or in your handouts, in your answer, you can use arrow to cancel answer and write equals 0. You can write an arrow to cancel and write equals 0. You do integration. This one, you substitute the equation 28 plus 3s kilo Newton. Kilonewton. So that's why there is a 10 power 3 there. There's a 10 power 3 there because it's kilonewton. In this equation, you have to consider unit SI. Force is Newton. Mass is in kilogram. Displacement is in meter. Right, and the trick that you will see in a test or exam is we are playing around with the unit. Sometimes we give you cm, sometimes we give you mm, millimeter, sometimes I give you ml, water, and I give you the density of the water. You need to convert volume into the mass of the water, for example. Okay, so okay, this is just a substitution of all the parameter here. Okay, so again, the integration of this one is under mathematics work, so I consider as a homework. Do your homework. You polish up your integration steps here. At the end, this equation only left out one unknown, which is V2. So you'll get your answer in the equation form because the S will change according to time. All right. So this equation, you have a parameter S and V in one equation there. All right. And in this question, once you find the general equation for V, you substitute S equal 3 inside here. Okay, 3 inside here. You'll get V equal to 5.47. Right? Of course, you say, hey, Dr. Ang, can I substitute my S3 inside here? Inside here? The answer is yes, you can. Right? The answer is can. You can substitute straight away in the equation of work and energy here to find the velocity when it reach 3 meters from this original position. So V equal to 5 point something meter per second. Again, important. The unit is important in your answer. Again, if you forget to write your answer, your unit, 50% discount for the marks. If this one carry 3 marks, you forget to write the unit, the marks you score for the final answer will be 1.5 marks. Okay. Okay. Any question for these slides? Any question? Any equation that you are not sure?
No question, sir.
Okay. Give you another 5 seconds. If you have a question, stop me before I move to the next slides. Okay, so I pull my answer to my left hand side, right hand side. My V have an equation, and this is the velocity when my displacement or my position is at 3 meters. I get 5.47. we need to find the time. How much is reached from 0 to 5.47 meter per second? Or what is the time it takes from 0 to 6 meter? All right. So we know that we have velocity here. So again, recall the definition of velocity is distance divided by time. V equal to ds dt. Okay. So what is your V? Your V equal to this equation. Your V equal to this equation. V equal to square root something with the S inside. This is your V equal to ds over dt. You know that you can move your t to left hand side, move your s term, the whole thing to the right hand side, and then you integrate both sides. Once you move your dt to one side, ds to one side, means left hand side all is t, right hand side all is s. Then you integrate. Okay, you get this form. Okay, how you get this equation? From the definition of velocity, v equal to ds over dt. How you get this equation? From the previous calculation, the velocity equation. I use exponential unit because I know I need to integrate. This exponential half is equal to square root, because if I carry the square root symbol in the integration, it doesn't help much, right? So when you do integration or differentiation, we always like to change all the, we always like to use the exponential numbers, right? So this forward, you know that you have dt, you have ds. The next step is integrate both sides. Again, I won't go deep into integration steps with this kind of setup, right? You use the cross product or product rules. Right. So if you don't know what is product rules, go and find out in your advanced mathematics textbook how to integrate this kind of equation. 1 over something. Okay, you get this form. T, okay, dt, remember if you add an integration, there's always 1 in front of the dt. So you integrate from 0 to t. Here you integrate ds from 0 to 3 meter. Okay, some integration step here. You need to open up your advanced mathematics or max 1 or max 2 when it comes to integration chapter. You integrate 1 over something, ax plus, you need to integrate a quadratic fraction with square root. Okay. Okay. So this is the equation. When you integrate, on the left hand side you get t, right hand side you get the integration equation. Right, homework. To do integration, when you integrate, substitute the 3 inside the integration products, get t equal to 1 point something, t equal to 1.79 second for this example number 3. Any question so far?
No, sir.
Good, yeah? All right. Oh, sorry. Okay, next we look at example number 4. Okay, we go for one more example, then call for a short break. So example number 4, apologize for my slides. I forget to hide all these things. All right. Okay, what we have here, example 4, is that inside the amusement park or water theme park. So in the water theme park, this guy here climb up the ladder. The height is 7.5 meter, and then it slides in a curved surface with the y equal to something x power 2. The distance from A to this point origin here is 10 meter. Then it slide into the pool. Before you solve, you look at the question itself. You know that this is yx at origin here, B. One thing that is very interesting here is y equal to something x squared, which is a curved surface. When you have a curved surface, you know that you need to use normal and tangent axis in the question. Straight away, you recall what you learned in curved linear motion. You need to establish N and T in your free body diagram later. Okay? So this is the first steps. When you look at the question, you already know what is the expected steps. Right? Curved linear motion, a curved surface with the object sliding on it. Always the next steps in your free body diagram, we expect to see normal axis and tangent axis. All right, so go back to the tutorial question, or example number 4. You are given the mass of the boy or the object m equal to 40 kilogram. This is normal, right? Previous example 3, we are given in megagram. So this one given in kilogram, which is in normal. You don't need to do any conversion. Slide down a smooth water slides. The word smooth here save you a lot of work, because smooth, the word smooth means without friction. If no friction, then you don't need to consider the friction force. If he start from rest at A over here, start from rest, slide down to B. His speed, determine the speed when he reach B, and a normal reaction, the slides exert on the boy at this position. We need to find the normal force acting at position B. So what is the steps we do? So you look at the question, you look at the statement, what information given? A curved motion, y and x. The question asks you to find speed, asks you to find normal forces. You are given the velocity from rest. You are given a v, you're given a m. So think of the principle of energy and work. You are given the mass, you're given the velocity. So, and then with the displacement, you know that you have a displacement. So you have force, right? You sure have force. So you have force, you have displacement. So you have work done. All right. So the next step is draw your free body diagram. So I just find a boy vector there. So a boy vector there, the first force is the gravitational force going through the body or center of mass. Right. So this is the pathway along the sliding here. So this is a collinear motion. So I just use a curve there just to represent at some point along this distance here. Okay. So along the point, I know I need to draw two axes, which is the normal and tangent direction. The boy is sliding from A to B, so your T is going this direction. Okay, don't flip the direction. Normal always pointing to the center of your curve. Normal axis always pointing to the center of your curve. So that's why normal going up, tangent going there. Weight always pointing down, no matter what is the curve look like. always going down, W equal to mg, and there must be a force holding the boy from shooting into the air. It is a normal force. Okay, so as long as there's an object contact with the surface, as long as there's an object contact with the surface and do displacement, they always have a normal force. Remember, write this one down in your revision notes there. Every time you have an object, no matter it's a car, it's a boy, it's a something, object, contact with the surface, whether pulling a box, the box is contact with the surface and slide along the surface. When there's a displacement, not displacement, when they have a contact surface, then you have a normal force perpendicular to the contact surface. Normal force always perpendicular 90 degree to the surface. Okay, I write as N sub B, why B represent the boy normal. Normal force on the boy. Okay, stop me if you're not able to digest this diagram. This diagram is somewhere along A and B point. So what happened at B? This is somewhere around the A. Does the diagram change a little bit at point B? So you should able to reason out, right? When it changed from A sliding along, when it reached B, there's something changed in the diagram. Same boy, but your axis rotate already. Okay, your axis rotate already. So since you still have the two axes there, with its normal and tangent also, but your axis rotate a little bit, right? You can see here, you can rotate. Okay, here, you can rotate. So you have normal, again pointing to the center of the circle, center of curve. Where is the direction this boy go? To the left. So this is tangent. And the weight still pointing down. Weight always pointing down from the center of gravity. Of course, you can move. Sometimes you want, when I prepare my slide, sometimes I want to emphasize on the normal. I will move my weight arrow a little bit up, but it's always through the center of mass or center of gravity, right? I can move my force going up as long as it's along the force line here. So mg going down, normal force always perpendicular to the surface. Normal always 90 degree to the surface. Okay, there's a difference from along the slides, and when you reach B, there's a change of free body diagram. Okay, stop me if you're not able to relate what is the difference between left diagram and right diagram. Why you want to find the B? Because the question asks us to focus on B. Okay. So I move from the first diagram first. I use the principle of work and energy on the first diagram, meaning I use the principle of work and energy to find the general equation from A to B. What is the equation I have? Again, write this general equation in your answer. You have some point there, just in case you did a wrong calculation for the rest. This one at least will give you 1 to 3 points or 1 to 3 marks. If you don't write this one and the rest you do wrong substitution or you press the wrong button, I cannot help you. This is the area that I can help you a little bit. So T, kinetic energy plus the work equal to kinetic energy when is done when it is done. So 0.1, 0.2. Okay, so I just modified the general equation from 1 become A, 1A, 2 become B, 2 become B. And then you expand this equation. What is the kinetic energy? Half mv square. The V is at A, this one, half mv square. The V for this one will be B. What is the work? Work again, work related to your free body diagram. As long as they are work or they are forces, then they are work. So here, half mv a square plus ws, because work done by the gravity, plus the velocity at point number 2, or kinetic energy at point number 2, or B. Y and B missing here. Why your normal force missing in your work here? Okay, let me ask question. Vinod, are you there? Calling for Vinod.
Yes.
Vinod, why on the slide here the normal force is missing in the work equation here? Why?
So
Okay, I got you a little bit.
it's a perpendicular to the motion, sir.
Correct. So when it's perpendicular, what happened to the work?
Sir, it becomes 0.
Correct. Right, very good, Vinod. So again, recall what is work. Recall what is work. Work is force and displacement. When force and displacement go in same direction, you get positive work. When your force is perpendicular to your displacement, or in this case, your normal force is perpendicular to the displacement, there's no work done because cos 90 equal to 0. And if the force go opposite direction with the displacement, you get negative work. So in this case, your W going same direction with your S. Why? Because this object going from this location to this location, so the object actually falling in Y direction. So this is the positive displacement direction, going Y, going down. So your W, same direction with your S, you get positive work there. So there is a positive and negative sign. You need to be clear and firm on why there's a positive and negative sign. So basically, if you understand this one, the rest is just substitution and solve for the unknown. Okay, if you understand up to this stage, you are good already. Means you can solve all kind of question when it relate to work and energy. All right. Okay, the rest I just be kind to you. I just substitute and do the calculation for you. All right. So sometimes you need to calculate this one as your homework. All right. My job here is to lead you so that you understand the concept, right? But because the numbers we will change in real life, and also you will change in final exam and also your test, right? So the first one, you start from rest. Here, if we start from rest, so again, kinetics equation, kinetic energy at point A is 0. W, you substitute mg. Displacement 7.5 here. displacement S here is about y. It doesn't cares about the distance of the curve. So don't confuse with the distance traveled by the object. We are more interested in the position rather than the distance contact of the object. So don't confuse with the displacement here and the y here. Your work displacement is where does it move. So here your weight move from A to B. This is the S value, 7.5. Take note there. Don't go and calculate the displacement or the circumference of this curve. Your S or displacement is here. Then this one is 40 VB. So basically this equation only left out VB. Okay, VB equal to 12 something. Again, unit is important. Okay, so this is quite direct. We have done an equation when it's moving along the slider here. You get VB. Okay, so you know that when it slides with a smooth contact surface, it means the velocity we assume will be the same. Let's look at what happened to B. Okay, so B, you know that when you reach B, your normal is perpendicular to the surface, contact surface, NB, and the weight still pointing down. So equation of motion here, F equal to ma. In this case, we find the normal forces because we only have normal forces. We don't have T direction. And our normal forces, positive direction going up because our normal axis is pointing to the center of the curve. So positive direction going up. Okay, center of the curve pointing up. Okay, positive going up. So F equal to ma. On the left hand side, you put all the force. NB positive because normal going up. Weight going down minus weight equal to ma. Again, recall, this is a very popular equation when you try to solve the normal and tangent question or curvilinear equation. Remember, this is very important. Will not be given in exam. So every time you solve a curvilinear, expect you will be use this equation. Acceleration at normal direction is v squared over rho. Rho is the radius of the circle. Okay, so this one you need to recall. Every time you have a curvilinear motion, acceleration at normal direction given by v squared over rho or v squared over r, the radius of the circle or the curvature. And you know that there's a one equation specifically to calculate the radius of the circle, right? You have to recall it come by package one, meaning if you see curvilinear, you're sure you need to calculate your an equal to v squared divided by rho. Sometimes your lecturer very kind to you, it will give you the normal acceleration straight away, so you don't need to calculate this one. But however, when it comes to final exam, sure we want to test whether you know there is an equation to calculate acceleration and normal. So sure you need to use this one, v squared divided by radius. Okay, there's an equation to calculate the radius of the curvature given by 1 plus so on. We already explained how to get this one already. So you calculate this one by differentiation. dy dx, you are given the equation of your curvilinear motion here. Y equal to something x squared. So dy dx, you do the differentiation. And bottom one is a double differentiation, or you differentiate 2 times of your y equation here, right? So once you get dy dx, you differentiate one more time, you get d square y over dx squared. Okay, if you forget what is this one already, go back to chapter 1 or chapter 2 lecture videos when we explain curved linear motion problems. Okay, so at this moment, if you manage to capture this equation, and this equation, the rest is just substitution, because you can find your NB, because here you can find M you have, G you have, M you have, velocity at B you already find just now, rho you do your differentiation step here. So basically this equation you will only arrive at one parameter. Okay, so your rho, just a reference answer for you, rho equal to 6 point something, and for this module, minimum 2 decimal place with the unit, maximum 3 decimal place with the unit. Okay, so I put in all the answer here. You only left out one NB if you substitute all the value. NB equal to 1275.3 Newton. You can write in kilonewton, or you can left your answer in Newton, or you can rearrange your answer into 1.2 kilonewton or 1.275 kilonewton. Okay, this is how you find the NB. You solve the question. Excuse me. Any question so far? Everyone good?
Hello, sir.
Good, yeah? All right. So we will go through a lot of cases where we do collinear. Later we look at the pulley cases. Sometimes we look at spring cases and so on. Yeah. All right. Let's just stop here for a while. Let me stop the recording.